Hi and welcome back to a new video. I'm pretty sure you remember the ASUS RTX 5090 matrix that we investigated and tested a couple of videos ago. Unfortunately, well, first of all, luckily I had the first card that was spread out to media, and I was lucky enough to be the first one to test it and then share it on YouTube. Unfortunately, it was a sample and I had to return it the week after, which I also said in that video. What I also said in that video that this is a card that is it just from a neutral standpoint doesn't make much sense to buy it, right? It's just a little bit faster than a normal 5090, but it's much more expensive. But I mean, there's not much I can say about it. I'm a victim of myself, buying these kind of things. So I decided to buy a matrix myself. There it is. So that's my own one. And just looking at the current RTX 5090 pricing and how the prices are increasing, that was maybe not even a bad investment. And what I want to test in today's video and check out is if the liquid metal application is exactly the same as what we had on the sample. And then I also received 3 very special power connectors from BTF to 12V high power that ASUS provided to me. You're looking for a real alternative to Google Drive or Dropbox, fully GDPR compliant, fairly priced and hosted in Europe? Check out StorageShare from Hetzner. As one of Germany's leading hosting and infrastructure providers, Hetzner delivers not only powerful servers, but also secure and flexible storage solutions based on Nextcloud. We have been using this Nextcloud and Hetzner solution for several years now at Thermal Grizzly, and I can absolutely recommend it from my own personal experience. Share files with colleagues and partners, collaborate on documents in real time, and manage appointments with the integrated calendar. No minimum contract term, no cancellation period. Get your own personal storage share now just with a few clicks. Find out all information in the link below. You might remember a few weeks ago there was the rumor that there was a recall on the RTX 5090 matrix that was, for example, shared on video cards. Then nothing really happened. Then ASUS denied the recall. It was shared again, for example, on video cards. And then the card eventually went on sale. But one thing I know is that after my video, the card was supposed to go on sale much quicker. And there is definitely something to it. I also know from a couple of shops that they received matrix cards and they wanted to sell it, and then they had to return it to ASUS, and then they received it back like 1 or 2 weeks later. So I'm not quite sure what happened, but something happened for sure. But we now also know that the cards went on sale, that they are fine, a couple of people tested them already, and I also bought this one, right? Just normal in the shop. That means the card was not fully recalled or there was a big problem, but maybe they checked something just to be sure. And I'm not sure if that's part of it, but I was just wondering because it might be related to my video I was doing, and I was not super happy about, for example, the liquid metal application, and that's why I just wanted to check if there is something different on this one versus the sample I received very early, and if the retail looks just exactly the same. I first tried to figure out if there is anything different from my sample to this retail one, just when it comes to outside appearance or anything, design. But I checked as much as I could remember and also double checked with the footage that I took back then. But there seems to be nothing different when it just comes to the looks from outside. So all of this looks absolutely identical to the card that I tested. Even though I often opened cards before I tested them, in this case I just want to be sure and take some measurements before opening the card. So I will plug it into the test bench, try to get some temperature data so we know at least what the stock condition was. I also noticed this on the sample that it's not quite convenient to remove this cover that is sitting on top of the BTF connector. And that's also a space where you do not want to, use a screwdriver to remove it. You would want to use your finger or some piece of plastic to be careful, but it's not quite convenient to take this off. And there we also have a fresh and new, not modded connector. What I quickly want to mention is that unfortunately this card is not compatible to the WireView Pro II for 2 reasons. First of all, the connector is just too deeply recessed in here, and then the WireView collides with this portion right here. So unfortunately in this state, this tool will not be compatible with the matrix. But I made my own version of the WireView with a cable attached, and this one would be compatible. There's also the different workaround where you could take a normal one, unmodified, and use an extension 12-volt high power cable. That would also be a workaround to make it usable with 5090 or 5080 Founders Edition. But you would add one more point of failure in theory. Well, you have the WireView in between, so the risk is probably a lot lower. But yeah, that's why we want to have this version also retail available with cable soldered directly to it, and we will also have more accessories to it. So we will slightly modify the cabled version that you will be able to buy in about 2 or 3 months with more like mounting options, because like this it would just hang around in your system. Not that nice. You would still have to find a solution yourself, but for the version that we want to offer, there will be options to mount it directly on your system. And that's how it would look like, how it works. And there I could also see that a good portion of the power is going through the BTF connector, because I was just observing the boot phase, and also now Windows idle. You can see Windows idle 3 or 4 watts across 12-volt high power connector. That would not be enough, so a good portion is definitely going through the BTF connector. And now putting some load on the card with Thermic, I can see in GPU-Z that the card is just pulling above 700 watts, so it's like 720 watts. And now I can see on the WireView that we have about 320 watts going through the normal 12-volt high power cable. That means that about 400 watts should go through the BTF connector, which is in the end also another 12-volt high power connector. So that one is going through the back of the motherboard right here. And I'm just thinking if I could in theory hook up a second WireView to that one, maybe with an extension cord. It's maybe not a bad idea. It's a nice coincidence that Eric out of our R&D department was just testing exactly this today with this extension cord. So I just borrowed, or should I say stole it for a moment. And this way I have 2 WireViews connected. Left goes to 12-volt high power, right one goes to the BTF connector. I launched Thermic again, this time a bit higher resolution so I can put more load on the card. And it's quite nice to see how the load is split up between the two. So we see about 400 watts on the 12-volt high power, and then 360, 370 on the other 12-volt high power, which is essentially the BTF connector, so the one on the right. But I would say the split between the two is executed pretty nice. And this way we can also check the current distribution between the 12 pins, which carry 12 volt each. And we see this is pretty even. Now this is cool and similar to the MSI Lightning that was just announced, because essentially this card is carrying 2 12-volt high power connectors. The main one on top and the secondary is just supplied through the back with the BTF connector. And even though the card is pulling more power than usual with up to 800 watts, it is still a lower risk on the 12-volt high power connector. As you could see, it's being split up in 2 times 400 watts. And this looks absolutely great. Even after 20 minutes under load, nothing is happening. The current distribution looks good, and even the temperature is not high. We're just below 40 degrees Celsius. That means that the fans won't even start. So this scenario is not yet comparable to my first video, because I was running 3D Mark Speedway and here I'm running Thermic. But in the 800 watts Thermic scenario, we can see a fan speed of about 2000 RPM and the GPU temperature is at about 72 degrees Celsius. That's the scenario I tested last time with up to 700 watts under load in Speedway, resulting in 1600 RPM and about 68 to 69 degrees Celsius on the GPU. And our next step is that I want to open the card and check the liquid metal application. I also like how easy it is to remove the cooler on this card. You just remove a couple of screws on the back plate, remove this spring mechanism, and then you can almost take it off. So that's very convenient. Okay. I kind of had the feeling that they were adjusting something, but I did not expect such a huge change. We can see a pattern of multiple strips of thermal paste, like different applications, and in the center, at least on the cooler, you can see the residues of liquid metal. And the same thing, of course, on the GPU side. We can see again the pattern that we investigated already last time when it comes to liquid metal application, which turned out fine thermally. But now we have this array of different thermal paste patterns or applications. First, we have a ring that is opened on the right side. Then we have a strip left and right. And then we have those U-shapes on top and bottom. So it's like a double layer, which would prevent the liquid metal from coming out with like a double protection. But at the same time, it's also open. Like you can see the opening here and top, bottom, and also here, which would allow this thing to kind of breathe. This should confirm my initial thoughts on this case. And also, if you look at this, this is much more professional. So the card that I got the first time, the review sample, looked like a manual application of thermal paste, you know, just going once around the die. Whereas this is a very professional, and for sure this is a mechanical, like a dispensed application, where a dispenser goes in the path that you define. And I also find the pattern itself absolutely interesting, because typically you would want to avoid that gallium is making, or the liquid metal is making, unnecessary contact with oxygen, because oxygen will lead to quicker aging of the liquid metal. But here they deliberately took the route of having those open spaces inside that the internal area can kind of breathe, right? So they left some openings that air can go in and out for whatever reason. Obviously, I know that when things get warm, they expand, so there's some thermal expansion for the air that's also inside. I'm not sure if that is the reason, but very interesting choice, very interesting choice. One thing is quite weird. I just thought, okay, I'm just reapplying the liquid metal, take a cotton swab, and I can't reapply it. And there's like a weird stain on the GPU now. I'm not sure. I have not seen this before. It almost feels like there's something else, like this is maybe also one of those hybrid liquid metal things with normal thermal paste mix, because this grayish stuff that I'm seeing and the fact that I can't spread it is odd. I want to investigate this further, so I'm just going to take a sample. You can already see it on camera that there is definitely something grayish or brownish between the liquid metal on here. It's just very useful to have your own SEM. Maybe we can find out what it's made of. At least we will be able to do a material analysis. So there in the center, we already have our sample. We can already see some liquid metal top right. Also, this is definitely liquid metal, but the stuff in between, not sure what it is. We'll just keep zooming in. I'm trying to do an EDS analysis, but it's not quite clear sometimes. At least we can see that the majority of the stuff on the left, so what is like teal colored, that is all gallium. We see a huge amount of carbon, which makes sense because that's the carrier material that I used to stick it on. We have a bit of oxygen. We have silicon, which is interesting. A bit of copper, gallium and indium are the majority. So we know that all those tiny bubbles on there, majority of this is liquid metal. But we have some zinc, as you can see here, the green stuff. Some silicon inside. So I'm not sure if this is maybe some sort of a hybrid paste or something. It's definitely not easy to see, but I think I figured it at least out to some degree. So if I keep zooming in, I think already in this kind of magnification, which is about 1,700 times, you can already see that there is some sort of material surrounding the liquid metal. So everything that is bright, like all of this right here, those are liquid metal drops. But there seems to be another material present. So if we keep zooming in, to something like close to 10,000 times, you can see that, so this is all liquid metal, right? And in between, there is a different material that is present. And at least silicon is detected here, and oxygen, which kind of makes sense that at least a very little amount of silicon oil is present in the material. And that would also explain why those small drops have this, I would say, odd shape with almost looks like they're cracking. I still don't know exactly how ASUS is doing this, but it looks like just a pattern that they're using some kind of like a printing technique. And maybe they need to partially dissolve the liquid metal in silicon oil to break it up in very tiny droplets to be able to use this like printing technology for mass production. That's the only assumption I have for this. And that would also explain why the liquid metal does not stick anymore if I wipe across with it, like with a cotton swab, as you could see, because then I would probably attach most of the silicon oil to the chip and the liquid metal would simply not stick to this, which means that I just have to clean the chip manually myself to be able to reapply the liquid metal. And here's also a high resolution image I took out of the SEM of the liquid metal if you're interested in investigating this further. It's pretty much impossible to clean the chip without removing the paste that's surrounding it, which is okay to me, but I had to remove everything and now I will reapply liquid metal. I reapplied it to both surfaces and now I will mount the card again. Now I want to add the card back into the system, again on the BTF motherboard, but without using the motherboard BTF connector. And that is because ASUS provided some BTF to 12-volt high power adapters to me, which is very interesting. I think they're unreleased. I have zero information about this. They just said, we will send you some adapters. I received them. I saw they are BTF to 12-volt high power adapters, and I'm pretty sure I saw this one before somewhere on some image, but yeah, I have no context. I don't know if they plan to ever release them, but I think they're quite awesome, and I just want to try them. This one, I think, is the one that is closest to being a retail product, even though there are no markings or anything, but you can see it's just a simple BTF to 12-volt high power, and I think this one, they're basically the same, I think, just without and with casing, just the adapter. And then there's a second version, which is also 90-degree angled. And what is cool about this is that with these kind of adapters, you would be able to use this card on any motherboard with full capacity, like full performance, dual inputs, so BTF and 12-volt high power, because you could simply use this instead. And I think I will also use this one. This should work the best for my case. I think they maybe made this for a different product because it doesn't perfectly fit. Almost collides a bit with the backplate. You can see if, yeah, it's a bit angled, but maybe if I just push it in. Looks all right to me. That's how it would look like. You have the secondary on the bottom and the primary, just the one on top. I'm not even sure why I thought this would work. I mean, obviously the connector would have, of the motherboard, would have to plug into the card, which is not possible because the adapter is in the way, so kind of conflicts, so that wouldn't work, but yeah. But the obvious solution is to go exactly this way. It was probably also intended for that, and that is running it with a riser cable, also vertical mount, because obviously things are flipped here, right? I'm using a flat test bench, which in a normal system would be upwards, and you would see the card horizontally. And in a case, you would have exactly the opposite again. So this would be the vertical mount on a riser cable, and probably for this, the adapter was intended. So I hooked up everything, wired everything up, and now I want to start the system again. And it's definitely, as you can see, working. And now running Thermac again, just to also double check if my liquid metal application is fine. Power draw looks also as intended. We can see about 400 watts on the back, on the usually BTF connector, also with an okay current distribution, so the current distribution across the pins looks alright. Same goes for the primary connector. See about 360 watts there. Current distribution also looks normal. I completed my testing and everything looks good. Clock looks good, temperature. I just noticed that the GPU fan speed is slightly lower than previously when I did my first test. Even though the fan speed is slightly lower than in the previous test, it doesn't necessarily mean that it was caused by the liquid metal application. It could also be the orientation of the cooler. That is something we at least learned from the drama around the 7900 XTX cards, that the orientation might matter, especially when vapor chambers are used. The other story is this entire liquid metal thing, which I think is super awesome. At least the way they executed the application now. Not the entire communication, they could work on this topic, but it's also understandable to a certain degree. But the fact that they probably saw how it was applied on my sample and then decided that they want the product to be perfect, take them back from the stores, and I don't know, you know, if you take 1,000 cards back and reapply liquid metal and this thermal paste ring, that is a lot of effort, and that is also a costly effort. And then doing all this, ship it back to the customer, make sure it's perfect, that is something I absolutely appreciate. So thanks for doing that. And I also think that all the Matrix customers will appreciate that you went down the route to make this actually perfect, also when it's just a small detail. Another thing is the communication. It could have been more straightforward because I think people would appreciate that you actually did all this, but I can also understand it from a business point of view. Obviously, you would not want to admit this in public. You would always want your product to look perfect, but it's perfect now. And if it's perfect at the customer, that's the only thing I care about. And I think that's also the only thing the customers care about. So thanks for doing that. And also thanks for watching this video. See you next time. Bye-bye.